about 0.1 volt decline between the peaks. This decline in voltage is called a ripple voltage. And the more ripple you have, the less stable your supply is. So this is pretty good, 0.1 volt ripple. We know that increasing the size of the capacitor gives us less ripple voltage. We have a smoother voltage available to our bulb. What happens when we change the size of the load? I'll look at the properties of the bulb. We have a power property here. I'll set the power property to 10 watts from 1 watt. Effectively, what I'm doing is I'm decreasing the resistance of the bulb by a factor of 10. So we'll go and we'll run an analysis, transient, 0 to 50 milliseconds. And we can see that our ripple voltage has increased quite a bit when we increase the size of the load. When we look at this area between the positive peaks, what we're looking at is a capacitor discharge. Capacitor discharge is governed by RC time constant. When we increase the C, we put in a bigger capacitor, we had a longer time constant, and therefore in the same amount of time there was less discharge and less ripple. When we increase the load, we're decreasing R. With less resistance, the time constant is shorter, and during the same amount of time we get more discharge and more ripple.
Okay. So I will briefly summarize all those things that we have seen. What are capacitors, different types of capacitors, operations of capacitors, series and parallel combinations of capacitors, how is energy stored in capacitors, different applications of capacitors that we saw. So I think it will be fruitful for all you guys. You can always contact me on my email ID, that is sachin.sharma@bapujkv.ac.in. Your suggestions, your feedbacks are always welcome. Thank you.